By the 6th century BC, Indian scholars were rapidly pushing the boundaries of medicine, astronomy, and philosophy. But this explosion of inquiry brought a serious problem. Without a universal method for proving claims, researchers had no reliable way to separate rigorously tested facts from deeply held cultural myths. To solve this, a structural framework known as Nyaya, or the science of right judgment, was developed to act as a universal filter for truth. Ancient seers actually required students to master this logical framework before touching advanced subjects like medicine. They called it the lamp of all sciences. Nyaya does not dictate the nature of the reality being observed. Instead, it functions as a mechanical rulebook for the operation of thinking itself. In this period, logic wasn't viewed as a separate subject, but as the foundational instrument that every other science had to presuppose. The primary tool within this system is Anumana, or inference. It is the mathematical bridge used to deduce hidden truths when you can't observe something directly. Take this classic scenario. An observer looks out and clearly perceives a thick plume of dark smoke rising from a distant hill. To process this observation, the observer must recall a specific memory judgment, a universal rule established by previous experience. All smoky objects are inherently fiery. By applying that universal rule to the current observation, the observer logically deduces that the distant hill must be on fire, completely bypassing the need to walk over and see the flames firsthand. This diagram breaks that deduction into 3 isolated components. We start with the subject, which is the hill. That connects to the sign, the smoke. And finally, that links to the object we want to prove, the fire. Inference acts as the critical bridge connecting our very limited physical perception to realities we cannot otherwise observe. If an ancient scholar wanted to prove a scientific point in a public assembly, they couldn't just state their conclusion. They had to construct a highly structured 5-part speech. This diagram shows the architecture of that argument. It stacks upwards through 5 progressive steps: proposition, reason, example, application, and conclusion. The arch's entire structural integrity rests on the 2nd step. The reason acts as the primary load-bearing pillar. Logicians called this specific load-bearing pillar the Hetu, or the middle term. To hold the weight of the argument, the Hetu must pass a rigorous set of criteria. It has to be explicitly present in the subject you are discussing, and it must never contradict observed reality. If that central reason is structurally flawed in any way whatsoever, the entire mathematical proof collapses instantly. These structural failures are what we call logical fallacies. In these cases, an argument might appear perfectly sound on the surface, but the middle term harbors hidden fractures. The first major point of failure is known as the irregular middle. This happens when the provided reason wanders and can comfortably lead to multiple, entirely opposite conclusions. If someone argues that a hill is fiery simply because it is a knowable object, the logic breaks. A lake is also a knowable object, but it isn't on fire. The reason fails to isolate a single definitive outcome. The second point of failure is the contradictory reason. This is a severe fracture where the provided evidence accidentally disproves the arguer's own proposition. For instance, if you argue that sound is eternal because it is caused, your reasoning destroys your premise. By definition, anything that is caused must be temporary, making it the exact opposite of eternal. Then we have the unproved middle. This error occurs when the entirety of an argument is built upon a fictional or entirely non-existent premise. You might claim that a sky lotus is incredibly fragrant, but since a lotus growing in the sky does not actually exist in reality, the entire foundational assumption is completely void. Finally, there is the contradicted middle. This happens when a logical deduction is directly overruled by a physical, non-inferential observation. You could construct a perfectly formatted syllogism arguing that fire is cool because it belongs to the category of substances, but the moment you extend your hand and feel the heat, your physical sense of touch instantly disproves the logic. Identifying exactly how an argument breaks under pressure is just as critical to the scientific method as knowing how to assemble one correctly. Beyond these internal structural errors, Nyaya logicians also studied external threats. They meticulously categorized bad faith debate tactics used to mislead public assemblies. One of the most common was the deceptive tactic of equivocation, or chala. As we see here, a speaker will secretly shift the definition of a specific phrase mid-argument, moving from an individual to an entire group, to completely manipulate the outcome of the debate. In the end, ancient Indian logic served as a universal quality control mechanism. It was a rigorous defense system designed to protect the mind from both internal cognitive mirages and manipulative debaters. A scientific conclusion is only ever as strong as the hidden links connecting its evidence.